So you just have to put some details about you, and you can download easily the program. After that, if you want to learn how to use it, you can enroll in a free course. It is available in metric and imperial units as well. And of course, the company has a YouTube website. You can subscribe, and it has many videos about different topics, and it helps you to learn the program. But I recommend to start with the free course because it starts with the fundamentals. Okay, so now I'm going to show you how this works. First of all, you need a topographic map, which contains points and polylines. You have to make sure that none of the points of the polylines has elevation on 0. After that, you can build surfaces. You can go to the surfaces to create and edit surfaces. Yes, here, because I have the trial version, I go with continue evaluation. And now, because I've already made a project, this is a project of a communal road, which is quite simple. I've chosen this because I want to show you just the basics, not to enter into details. So if you start with the creation of the surface, you will have to give the name of the surface, anything you want to give. And then you have to go to the inputs, and you can put the points here. You scroll and select the points and then add. Then you can put the break lines, which can be which have to be polylines. These mainly are from the topographic map which you have. It can be the center line of the existing road, the drainage ditches, the limits of the properties, and you can add all of these here. It's important because when the program makes the triangulation, it takes these into consideration. Here, if in the outputs, you can choose to select or deselect the mesh, which shows you the triangulation and the major and minor lines. Now I will uncheck these. Furthermore, you can show the slope arrows, which helps you with the design of the water drainage. It shows you the slopes. Okay, so I am going to uncheck this and click Update Display. Okay, after that, you can insert in the project a satellite image by going to this button. Okay, so here just select the category. I went with the national grids and the stereo 70, and you can select the place anywhere. If you click here and confirm the satellite data, the program knows where your construction is. And then you can zoom in or out and move the map. And it's important that it will show you just the image that you can see on your window. And then you can select Google Satellite or Google Hybrid, what you would like. And then click Accept. I won't do that because I already done it before. Okay, and after that, so now we have the surface, and we can go to the alignment to create the alignment and to make the curves. It's important that the alignment should be a polyline. I've already done this before, so I'm going to show you with only the command. I draw a polyline, and you may go here to create alignment, and click on the polyline, and you have to give a name. You can select the type of the string, road. You can add the description if you would like. Set the chainage, and here you can set the annotation style. It's important that when you create a project, it automatically will create a folder with the data of the project, and you shouldn't change the name of this folder. So the name of the folder and the name of the file must be the same, because otherwise won't get the data. And you can add from here any annotation you would like to add. Okay, so after that, if you click OK, and you have the alignment. I will delete this and show you how I made my road. So I go with the Edit Alignment tool. Here you can add IPs at the end or at the beginning or in the middle. To move, you can move IPs, you can delete or reverse the chainage. And to add the radius of the curves, you go with this button and select any of the IPs. You can introduce the curve, the spiral length, the end, and the...
Oh, pagar
You can as well introduce import XML files, or you can also go to the grid editor and introduce here the radius and the spiral. For us in Romania, we have a feature for the RDM, which helps us to build the roads with the Romanian standards. So we can introduce the design speed, the radius, and the road category, and it will automatically calculate every element of the road, and then introduce the data manually. Or we can also import from these to generate the file and to import automatically. Okay, so after that, now we have the alignment. And the next step is to go to the roads and make the road string with the vertical grading. So it's really interesting that as you go on the vertical grading string, you can see on the alignment where you are, and it's really important and a great feature that you can see in real time what's happening with your road if you modify something. For instance, I will modify the exaggeration because, okay. So for example, if I go here and move the IP from here, then you can see how it changes in real time, and it helps you. It really helps you in the design procedure process. To make the transversal section of the road, you can create templates with I will show you this one. So the program works with codes. for every point, you have a code. You can, the CL is the center line. This is for all of the templates, and the LEB and REB. But then you can add any code you want. But remember that for the left side, you have to put L in front, and for the right side, R. And for the same structures in the road, you have to add the same code, because the program knows it, and it will join the lines in the plan view. Mute.
Di portiet.
Da.
Ahora después,
Aí é por mim.
Ah, ma già passato.
eso es.
Nu are acces la fereastra de la AMI program.
Da. Okay, and now you can edit the subgrades, and you can add the materials and the depth of the subgrades, and also you can set the extensions and the slopes. Here in the transversal section, you can select the templates and add the chainage, the start and end chainage, and the type of template. You can add variations and so many more things. I want just to show you the basics, and if you are interested, you can find in the videos. Okay, so if we made the vertical grading and the sections, now we can go to the surfaces and to see our 3D model. This is how it looks. My surface is quite flat, so I'm going to change the exaggeration. It shows us the cut and the fill, and also we can make an analysis to drive through the road. We can set the speed, and we will see our road. We can reverse the direction, and the speed, we can change the speed also. So this part, this 3D modeling part, it's useful mostly for the highways and the major projects. I work just with simple projects. Okay, so now these are the basic features of the program. And now I'm going to show you some videos about the BIM part and about the file exchange tools. And now I'm going to show you the BIM part of the document. have any questions, please ask me and I will try to answer them. And if you don't have, then thank you for your attention.
Hello, my name is Mihai Șenilă. I'm teaching at Technical University of Cluj-Napoca, and my colleague Andreea Oanea, a PhD student, the same university, Department of Structures. Today we will present to you an example made in Tekla. In our case study, we want to design a building, a steel building. First of all, we will design the building in a structural design program. We will use SCIA Engineer, and after the data will export to Tekla, or we'll start in Tekla from the beginning to model our structures. After we finish the detailing, we finish the model, we will export the connection, the joints in Idea Statica. We will check the connections, and after this we will, by directional links to Tekla, we will change directly the model in Tekla. My colleague will start to present the structural model. We will use a plain portal frame for this example.
So we start with a steel frame where we have the loads like permanent, snow, wind, and after after the calculation we have in internal forces from the like the moments my. And
the shear force and the axial force.
I cannot hear you.
Sorry.
After running the structural model, we get the design forces. We'll check the structures for the section that we already modeled, and we will. Can you please show us how you check the model?
What type of elements did you use for beams and for columns? IP, AGA?
IP for beams, AGA for columns.
IP
300.
300.
Sorry, 400. 300 is for the columns.
Does the program allow automatic verification of the selected profiles after you have the bending moments and the stresses? Can you automatically design?
Yes, you can automatically design, or you can check the sections that you already set to the elements. So in our model, we
So you already checked the elements, or?
Yes, that
we already assign the sections for the elements, and using the load cases and the load combinations, we obtained the forces for the element, and we will make the checking of the sections.
So just checking.
Just checking.
Automatically design.
Yes. Of course, after this you can optimize the structures. You can select the beam, the column, and you can change the sections. You can change the steel. You can change everything.
yes.
When you design portal frame, you have to be sure that the elements are capable to take the loads in section, and also by the elements you have to make the stability verification checkings and the resistance checkings in sections, in also the
Frame.
yes, also the frame. After these two kind of verifications, you will need also to check the deformation of the beam at the middle of the span. Usually we use a fraction of the span, 250 normally for the normal beam, and this is for vertical displacement, and also we check the horizontal displacements at top of the column from horizontal actions like wind and seismic loads.
But what type of support do you have? A pin connection or rigid connection?
Pin connection.
Pin connection.
For this model, it's a pin connection. Usually for span that are over than 15 meters.
But we don't know how many meters you have.
22.
22. Okay.
And height 7 meters.
Height of 7 meters. The column is 7 meters height, or at the center?
At the center.
The column
And the slope? 5 degrees, I think. Yes,
Yes.
I think so. Okay, so we already checked the elements. I can see, arată te rog frumos verificarea, rațiile de verificare pe element.
Dacă nu,
Does it give like a report?
Știa?
nu, dar dacă dau licență, nu
La ce n-ai licență?
da știa.
Păi cum n-ai licență?
Pentru că e doar modul vizualizare. Da, ca și rezultate.
Também encontrei licență aici. Tu zici că n-ai licență. Pe cine ai licență?
The diagram.
I don't see
Dacă
like
folosită
the diagram on the column. Say that the diagram on the
Ce prezentare?
So from your point of view,
The node is not moving.
Okay, so what was the question?
no, we were just deflecting the subject. Okay,
This is the bending moment. So this is
Yes.
okay, yeah.
the other one was maybe shear force.
Yes, usually for the biggest moment at the beam is the joints, the point near the column. We make a haunch in the beam because the normal section of the beam is not capable to take this big moment. So we'll make this haunch. This helps us also with the deflection because it's modified the stiffness of the beam. I want to say also some things about the 3D buildings, the entire buildings. It's repeat. We have I cannot find my words. A plain portal frame that repeats at a span 6 meters or
5 meters.
5 meters.
The distance between the frame.
Yes, and we have how many portal frames?
4.
And we have 4 portal frames. Okay. Also, in the longitudinal direction, we have pine connections, and the stability is given by the bracing systems. Bracing systems X type.
The bracing
Bracing
is placed
systems.
also on the roof level and the column.
Yes, of course. Usually we put the bracing systems in the longitudinal direction in the first and the last span normally, but sometimes we can change this because we can get some big efforts in the
Lateral torsion.
in the facade columns, and this can be difficult to resolve. So in this case, we will move the bracing in the second span. We have also the bracing in the roof plans, of course. The purlins are made
C-section.
yes, and this is about the design. This depends. We don't in this case we don't use concentrated forces. You can help me to say it right. Because but we don't have purlins. We have purlins here.
It's
Sheeting,
yes.
still sheeting. I think.
But the
Purlins?
sheeting includes the purlins.
Anyway, the idea is when you
In execution.
are loading the building, it's better to have a uniform load, because in execution usually they change the section, they change the closing, the închideri, cum le spune? The facade elements, and in this case they will have to change also the distance between the purlins. So
Depending on the panel, which is
in this case you have to return in your design model
and
to run again, to check again, and For this reason, it's better to have an uniform load, and it's not important the distance between the purlins. When you have more than 4 concentrate forces on the beam, you can usually take like a uniform load. Okay, after we finish the designing, we start
Modeling the structure
modeling
in Tekla.
in Tekla.
So
Andrea, please show us.
we start a new project when we can take a name.
In this example, to show you how to use Tekla, we want to start from the beginning. We will not import the IFC file from the SCIA, from the design program. We'll start from
scratch.
Exactly.
First step, we have the grid where we will have two openings of 11 meters. Names.
You set up the coordinates on X, Y, and Z direction,
Yes.
and now you're inserting the labels between A, B, C, D, which are already there. Visible.
The second step is to make some views along the grid. Okay.
So you're creating the training for the frame, right?
Yes. And we start with the columns. We have columns with profile. Here is the dosage.
H320.
Materials.
S355.
And the height, I have 6 meters. Going up. View. It,
I think it's not the right direction.
we can rotate it.
It's necessary. We use the same column for the right position.
On the bay of 122 meters. It's the same model, right?
Yes, we are detailing the
Same situation like
the portal frame that we had designed in Scia. Okay, so we have the columns. After this, we have to make the beams.
Yes, that. But I think I made a mistake. We have this in
So the practical
Noi modelul
Tekla,
desenat.
it's only for the drawing part, right? I mean, we're not going to
Tekla, it's a software that allow you to detail, to model and detail the building, but not to design.
They have
Tekla structures. They have an alternative software to design and checks the buildings, the structures. But this so that we use Tekla structures, it's only for detailing. It's only to get execution plans for
and they will deliver all the drawings necessary for the execution part.
please do the BIM. Yes. You'll get all the execution plans. You'll get the bill of quantities, the list of materials, the assembly, cum îi zice, șuruburi?
bolts.
The
Bolts.
connections,
Also the detailing for the connections. Usually you'll get two kind of drawings from Tekla. It's a set of drawings that goes to the fabricators. We need also the haunch, please. That kind of plans is with a lot of data inside, because the fabricators have to execute them, the structure, the elements. And the second type of plans is the assembly plans that is necessary on the site. So we have the beams modeled. For these beams, we'll select and we'll apply a haunch. For this, we will select the type of connection. It's a connection between column and beam.
The main part is the column, and a secondary part is the beam.
The other things that it's important. It's after you model joins a connection, you can export it to Idea Statica. It's another software that we will use in this case study. We will check, design and check the connections, and after this we can export it back in Tekla. Normally we have a link between Idea Statica and Tekla. This is bidirectional because it's easiest way to use, not to export every time and import in the other program. You can use this facility of the program.
This connection can be modified, like the thickness of the plate, bolt size, and bolt distance.
Okay, so once that we have a connection in the left part of the frame, we'll copy.
We can save our connection. And on the other side, we can load the connection. In the middle, we have another type of connection. We can modify it.
This program saves you like a lot of time for generating the drawings.
The middle connections between beams is called usually apex connection, and usually is done with a small haunch, the same like between beam and column, but smaller. Usually, this kind of frames or connections, the joints for this kind of your frames, it's semi-rigid connections. It's not necessary to use a rigid connection for this, because to have a rigid connection, you will it's necessary to have a lot of bolts, and this means material, this means manpower, and this means money. It is not necessary. If seismic codes ask for this, and you cannot use semi-rigid connection, it's necessary to make a rigid connection, we will do. Okay, so we have also the apex connection. We have to set the column base. For this, we'll choose also from typology, from the library. Must be a pine connection. Normally, the training for the Tekla starts with model the environment, model the axis to draw inside the program. After this, you'll learn to handle with elements. After you will do this, the connections comes normally at the end, and for this it's possible to spend some days. This is done. We can show you, maybe it's the best idea to show the model that you already have done. Already had done. Hai salvat asta? I can't find this enough, so. Okay, so let's see some documents from this. This is we get the model, detailed model. After we have the detailed model,
We can
start with documents. Okay, Andrea, please show us the drawings plans.
We have multiple type of drawings, like single parts, assembly, multi-drawings, general arrangement drawings. So For general arrangement drawings, we have sections where we can.
Okay, this kind of drawing is assembly drawings. It's a drawing that is necessary on the site for the constructions to know how to put together the parts and what to use to keep them together. And also we want to see some execution drawings.
This is the column where we have the front view, lateral view, and section at the base.
This type of drawing you can personalize. You can clone it and use it for other type of other columns to have the same dimensioning and the same type of sections and positioning on the plan. You can present the plans more elements on one drawing. You can put it every element in one plan. This is the engineer choice.
So basically, you can create a template and which you can use in the drawing that you make.
Yes.
When obtaining
the difference between I already told you these two kind of drawings is the data that you will have inside. So you have to put data about the weldings, the holes that you have to make for the bolts, about the angle of cutting plates of the plates, and you can put a 3D picture of the element. This is usually only for looking good, the plans, because they don't need in the fabric. Oops. Okay, idea statica, live.
The error can transfer.
Okay.
We can show how you can clone the drawing. I can close this. For example, I will make a drawing about of this plate. Name of the we can add we can modify the scale. The name, and we can make section. Add dimensioning. And vertical dimension. We can change layout. If we want to clone a drawing, can select the plate, and now we select the drawing that we want to clone. And now for the new plate, we have a drawing, but our dimension it's not good. We can export material list where we have all the materials that we have in the project. And we can export our model in IFC, DVG, PDF, or other kind of format. Dacă să mai continui, dar nu știu despre ce. Dar nu mai știu despre ce. Nu. Da, dar nu în modul în care îl prezint eu. Nu în modul în care îl prezint eu. Hai, ajută-mă și vorbește.
Okay. Show me what you're going to do next, please. Ok.
Semnează semn de eroare că nu recunoaște butonul.
Licența a avut, ok.
Și atunci o să șterg cuvântul și dau o conexiune în Idea Statica.
Okay, so you're going to import this drawing in Idea Statica, and we might receive an error, but we're going to fix the error by okay, let's try to import the drawing in Idea Statica and see if the error shows up. Okay. Idea Statica is the modeling behind the drawing. It's going to do some calculation of the efforts. Okay. Okay, no problem. So, încă
we have our connections and we are trying to make.
Okay, let's see if it's going to make the connection. Okay, the analysis is finalized. Is there any errors?
Yes.
Okay. Is it because of the input of the? Okay, one of the elements is not recognized in the program. We're going to try and fix this error. Okay, the loads are not recognized by the Statica program, but let's see why this happened. Okay, we're going to redefine the loads and try to see if the Statica will work better. Okay, the loads were previously obtained by modeling institute. Let's see if the analysis in the Statica will work this time. Okay. This might take a short while.
This is a new connection or the connection from Tekla?
Is the connection from Tekla, right?
Yes.
The connection from Tekla was important in the Statica.
The connection that you modeled in Tekla?
Yes, imported in the Statica.
With the loads from the SCIA?
Yes, that's what we said before. Yes. Okay, we bumped into another error. Let's see why. It's still not recognized. The loads are still not recognized.
No.
Okay. Why is this? Are the loads rightly defined? Were they defined correctly on the structure? Okay. Poți să vă deschizi Tekla și să reimporți de asta, adică dacă la altă, puteți să zicem că încercăm la minare. Okay, we're going to now try the base connection. Okay. This connection is between the foundation and the column, right?
Yes.
Okay. It's now imported in the Statica, and let's define the load.
We can take overloads from the exported idea Statica from Scia.
Okay.
So,
Okay, the loads are now shown.
we have our port M.2.
That's the location of the column, right? Okay. And now we're going to try the analysis on this connection. Great. So the analysis was done and the results are as shown. The buckling was not calculated, but
Interpreted now.
okay. The second analysis is done. Now the buckling is also calculated. We're now going to show you the stress.
It's at the limit 0.
Okay. And the stress in the concrete element. We are now going to mesh the structure and to analyze the deformed shape of this connection. Okay. Now we are going to try and check the reports. As shown, please continue.
We have geometry, cross-section, type of anchors, loads, and
the results presented are for both structures, like for the entire connection, both the concrete element and the steel element. Yes.
And all the
entire analysis is presented here, step by step. Every symbol is explained. For, as we previously said, for both elements, both concrete and steel structure. They used codes, and the value for the safety factors are shown here. Would you like to try another connection? We tried a column connection with the foundation. Previously we tried a connection between the column and the beam, but there was some errors there. Would you like to try and go back? Perhaps we can solve that issue. Or let's try, will we try a middle?
Yes.
Okay, let's try a section in the middle between the two beams.
We need to go on.
Okay, we went back to Tekla, right? Okay, we're going back to Tekla. We're going to make a section and then import it in Idea Statica as done previously. Okay, please create the section.
We have on the bottom of the screen what we need to do.
Okay,
We select the beams and part of the connections.
okay. Thank you, Andrea. Next. The program will run and do its own section. Let's open the connection and see. Okay, so our section is now imported in Idea Statica. Some errors are here.
What? It's between plate 5 and curve. Plate 5.
That one. Okay, we're going to try and fix the errors shown on the screen. We're going to try and disable these two elements, or okay, we're trying to find the error and fix it.
Or we can delete the connection and
Re-upload it. Propose a new one. Okay, let's do that. Let's delete the connection and propose a different one.
I have.
Please tell us.
I have this connection exported from SCIA.
Okay, let's see the connection. Okay, this is a connection previously imported from SCIA. Great. Now let's try to analyze it.
We need first to make the connection between these two.
Okay, so we are going to propose a connection between these two elements. Great.
We can define another board.
Amazing. So we're going to propose and define another board. Good. As you can see, the bolt is now defined and we're going to proceed with this. We're going to check the structures geometry. Okay, we are going to define.
The distance between the bolts.
Thank you. Andrea is currently appreciating. She's approximating the distance. We're going to see if it lasts. If not, we're going to change it.
And we can try to see.
Okay, let's try to calculate it and see if the proposed structures held. If not, we're going to come back. Look, the buckling is not calculated, but the structure is lasting. It's good. Okay, let's now calculate the buckling. This structure has a buckling of 11.64. Now checking the stresses.
Plastic strains, stress in contact.
Okay, what can you show us about? Tell us a bit more about this. We're currently checking the stress in contact, and as we can see from the diagram, the proposed structure is in the parameters. It's okay. It's
yes.
Okay. Now we matched the structure. And now we are going to check the deformed shape. Great. Now let's see the report for this connection. As previously, the project, the idea statica presents us an entire resume of everything we have established from the proposed connection. Okay, we're going to try one more time the connection between the column and the beam, the one we tried before but was not successful. Let's import a new one from Stia. We are now going to import a different structure and propose ourselves some the characteristics. Andrea is proposing
maybe 400.
Okay, let's see if the structure, let's see if the connection held with this. First, okay, do tell. So first we are going to propose the connection between these two elements. And what do you say, Andrea? What are we going to propose?
This connection, I think.
Okay, let's try with this connection and see if it works.
And modify them.
Okay. You previously chose a very good connection. It held. Let's see if this one helps.
I don't think I'm so lucky
Oh,
this time.
and let's see. You might be. Let's calculate this structure and see if the proposed one helps. There should be more distance there, right? Okay.
This bolt.
Yes. Let's change the distance between those two bolts. Okay. Will those be enough? My colleague is very good at what she's doing. She's very shy, but she's very good at what she's doing. She's now approximating the needed distances, and she's not sure, but we're going to see. Okay, let's calculate the structure and see the results. It's taking a bit longer, but I'm pretty sure it will help.
I'm not sure.
Okay, as you can see, this is the first connection that does not help. We are going to have to go back and redo the steps. We're going to propose a different connection. Okay, Andrea, please go with us, and please explain the steps we're going to follow in case the structure is not is not lasting, is not having.
We can try to modify the bolts and the plates.
Okay,
We have.
so we are going to repropose the design. Please tell us which method you're going to choose.
I will try to make this plate more bigger.
Okay, we're going to choose a bigger plate for the section.
In my opinion, if you have
The plate,
the efforts from the SCIA, where you already
calculated.
have the hunch, this kind of connections, we need that hunch.
Okay, thank you for the input. We're going to follow your advice.
Maybe the sticker we can put
From the beam sticker or from the?
for the flange,
Okay,
the same level with the flange of the beam,
B1.
and
Just put it
also
down.
okay, thank you.
we need also one for the middle flange.
And also on the.
O să mai te nimeni.
Dar nu merge importată?
Nu.
Ok.
Continuăm. E bun.
Merge importată, dar nu îmi recunoaște încărcările.
So,
Manual.
okay, let's try one more time to import the structure and put the loads manually, not import them from SCIA.
This is the way to design.
Okay,
Not always, not
Trial
always
and error.
you will get
this is a trial and error type of analysis.
Maybe you have to come tomorrow. And tomorrow and during the weekend you can do it.
No, I think we're going to actually solve this issue today and finish today. Okay, so now we are going to try one more time to import the structure, the connection, and put the loads manually instead of importing them from SCIA. Perhaps this way the program will recognize our loads and the analysis can be made. Okay, we go back to SCIA. So this way we are going to analyze the entire structure, connection by connection. We've previously done a connection between a column and a foundation, then a connection between two beams, and now we are trying to fix and calculate the connection between a beam and a column. Thank you, Andrea. Okay, back to SCIA, importing the structure. This is the previous file we worked on. Going back to the model.
Internal forces.
Okay,
We can take our efforts in crisis. We have a torsional moment on the column and beam.
and now we are going to manually introduce the obtained efforts. Okay. Okay, the loads are now manually introduced based on the SCIA analysis.
We have XI4.
Okay, now checking the axial effort. And its value is
On the beam.
for the beam. For the beam.
Actual force in the beam. And the shear force.
We are lucky to have such paying attention audience today. Okay, my colleague has now finished in, the loads. We're now checking to see if we introduce the loads correctly, and now we are trying to calculate the connection. My colleague is saying that she's almost sure this connection is not going to last because the iteration lasts a lot longer. Okay, she's right. We're going to need to improve the connection.
But I think it's something else that it's not okay.
Okay, so this time the loads are not the problem.
The laws are not applied.
Okay, we introduced the loads manually and the program still not recognizes them. Any other proposal?
Înseamnă că e o problemă de modelare și export din Tekla, nu e bine modelată.
Restul conexiunilor l-a luat. Restul conexiunilor l-a luat. Pur și simplu modelarea între astea două elemente nu e corect realizată în Tekla.
Probabil.
Ok.
Cu o forță de 10 kg funcționează, ce status? Nu dă niște rezultate pe acolo, nu dă niciun motiv.
Well, it currently says the loads are not applied. The status, no, we don't have any reason.
De ce eroarea? Ce zice?
Asta era dacă forțele nu sunt aplicate. Forțele nu sunt aplicate.
Dar refă îmbinarea asta în ideea. E așa de modelat?
Ca să fac exact cum noi nu ai greșit pentru că nu le dăm astea de propuneri și trebuie să ne vedem acolo și să dureze.
Uite aici.
Asta? Da, de...
Ce?
Astea. Să înțeleg așa?
Okay, sometimes things doesn't work like you want. Sometimes you have to go home and come back with
But still NVIDIA has
more
shown
energy.
Still NVIDIA has shown us more than one connection and how to use the program. This was the proposed topic today, right?
The topic was to offer you an idea about to use the program, not to nu să vă învățăm să-l folosiți.
Okay, so the basic, this was a basic training.
Only to know about the program and how you can use it. If you want to know more, you have to go and train yourself.
That was
this.
understood from the beginning. I think Andrea did her part. We understood the basics about the program. She managed to make us more curious about the program.
Okay, so
The program does, so
I think we can.
conclude for today.
Yes, we can make data for today.
Let her try one more time this connection, and then we can call it today.
The height of the haunch must be bigger.
No.
The end plate must be longer. I think there is a bug somewhere.
This happens after each program.
This happens often. Modelată. Ok, hai că nu cred că l-aș urmează. Ok. Okay, we have too many balls for this.
Okay, step by step, just as we did before, one more time, and then we can conclude. We did a calculation.
Usually you can find the rigidity for the joints in Idea Statica, and also the
Show us how to check the rigidity.
the strain check is based on the component method,
Okay.
but is better.
Okay. Why?
Better. We have a
It has
presentation about Idea Statica if you want to know more about this.
Okay, understood.
We can start a presentation. We have time for this?
15 minutes. Can you finish the presentation in 15 minutes?
No. No, I think we will need more.
How much more?
I don't know. But and the deformed shape, please.
Okay.
Okay. So this is the results that we get, and you can get also the report and some drawings for the connection.
Okay, please.
The checkings is done by Eurocode 3, part 8, the connections. And for this you can have a lot of things. If you check all the boxes, you will get more information.
Okay.
Not. Okay, I have to refresh the window. So I hope you understand the workflow for this case study. We design in SCIA, detailing in Tekla, and check the connections in Idea Statica. If something happens in Idea Statica, we can return the information, the model of the joints back to Tekla. And also we can send back to SCIA to check once again.
Okay. So this process is much easier than another type of analysis.
Yes, it's a workflow that we like to use.
Okay.
You can use the connections and the checkings for the connections that it's inside of SCIA, but I'm not sure that Tekla recognize the all that you will export from SCIA, because Tekla have a problem with haunch.
Okay.
Or to be more specific, when you import an IFC file from SCIA, and in SCIA it's you
It's a different way to define them. So
somewhere is a small bug here,
Okay.
and we will find also this bug, and maybe
try to fix it.
yes, try to fix it. But in my opinion, this is the best way to do
Okay.
design in SCIA. When I say SCIA, I don't mean SCIA is the only one software to make design structural analysis. You can use also other software like GitHub's SAP 2000 and many others. But let's be honest, the engineers usually use the software that they know.
Okay. That's
And
true.
yes, of course.
Everybody will
And
do their best.
there is a word. The best software you can use is the software that you know. Okay.
Okay.
Thank you for your attention. If you have any questions.
No, I think the questions were pretty much discussed during the presentation. Thank you very much for your time. Thank you, Andrea.